7.2 starts with the exact same type problems that 7.1 ends with. So we take everything we learned in 7.1 and we're applying it to a variety of equations. So remember, one of the easiest places to start is to write your general formula underneath or above the equation you're given, and then compare what you know. So we have a positive 1, an implied positive 1 where a is. Because it's positive, it opens up. And because it's a 1, it's neither a vertical stretch nor a horizontal stretch. So we can move on. So your h value is this positive 1. So that tells us that it's going to go right. So a shift right 1 unit. And then we have our k value of positive 3. So that's up 3 units. The last thing we need to identify is the vertex. And remember, your vertex is hk. So h is 1, k is 3. Looking at the next equation, again, if it helps, write the general form underneath your given equation. So ax minus h squared plus k. And then associate. So we know the very, very first thing is that the a value is negative, which means it's a reflection over the x-axis, which is another way and a more mathy way to say opens down. So we need to be transitioning from this idea of opens down to a reflection over the x-axis. So the negative tells us it's the reflection. The 4, which is larger than 1, means that it is a vertical stretch with a scale factor of 4. Remember, the negative or positive tells us whether it opens up or reflects over the x-axis, and the number itself, so in this case the 4, tells us if it's a vertical or horizontal stretch. So the next thing we look at is the h value. So we have a positive 3 in there, so we have to subtract a negative 3 in order for it to become a plus 3. So your h value is actually this negative 3, which tells us that we go left 3 units, so shift left 3. And there is nothing added on the end, which means your k value is 0. So we're not shifting up or down. So our vertex. Vertex is hk, so your h is negative 3, and your k is 0, because there's nothing added on the end there. So for our next problem, y equals ax minus h squared plus k. So your a value aligns with this positive 1/3. So because it's positive, it opens up. And because it's got a multiplier of 1/3, that is a horizontal stretch with a scale factor of 1/3. Now, because there's nothing being added or subtracted inside the parentheses with your x value, that means there is not a left or right shift. So we have to look on the outside. So we have a plus 10 on the end, just like your plus k. So this is a shift up 10 units. So the vertex, your hk. So the h value, there's nothing inside of a set of parentheses with the x value. Therefore, your h value is represented by 0. because when you subtract 0, nothing changes, and it just leaves you with that x squared. And then on the outside, we have a positive 10. So that's the other half of your vertex, the y-coordinate of your vertex. So for the last one in this section, so your a value is this -1, which means it's a reflection over the x. And because it's a 1, it's not a vertical nor horizontal stretch. Looking at the h value, how do we turn -h into a +5? And that's if you're subtracting a -5. So your h value is that -5, which means we shift left 5. And then your k is a -7, so that's down 7. And the vertex. So again, your h value is that -5. So when h is -5, we're subtract a -5, which is actually addition. And then your k value is that -7. So your vertex is -5, -7. So for the next part, in order to find out the a value, you have to identify if it's open up, open down, and one other attribute. And then you also need your vertex because we're writing these in vertex form. So in order to write it in vertex form, the first thing you have to know is your vertex. So in this case, the vertex is 3, -1. Which means your h value is 3 and your k value is -1. So the only other thing you have to know is your a value. So to find your a value, you're trying to figure out how do you get to the next point over. So you want to go over one box and then go to your line. So how much did you shift up or down? 2. We went 2 boxes. So that means your a value is 2. And because it opens up, it's a positive 2. So now we can plug in everything we know into the vertex form of a quadratic function in order to write the equation. So we have y equals a x minus h squared and then plus k. In this case, it's -1, so we're going to put -1. And that's the equation for that parabola. So for the next one, we're given this. So our vertex is right here at -3, 4. So -3 is your h, 4 is your k. Now, in order to find the a values, remember, you're going to the next box over. It doesn't matter which direction you go because it's symmetric. So when we go one box over, we go half a box down to get to your line. So your a is half. But your parabola is also opening down, which means it was reflected, which means it's a -1/2. So now we can write the equation for this parabola. So we have y equals, it opens down, it's negative. To get to the next box, we went over a box and down half. X minus h, your h is -3. So when you subtract a negative, you're adding 3. And then plus k, squared, and then plus k. So we have plus, your k value is 4. So again, because it was a -3 is your h value, the x minus h became x minus -3, which is the same as x plus 3. So on to the back of the page. So the vertex is the turning point. So if you look at this graph or this table, and you look at how the numbers are changing in this table, you'll be able to identify your turning point. Also, you can watch the numbers kind of fold in. So we have 7, 7, 2, 2, 1, 1. And then there's that bottom line. So this is your vertex. So on either side of your vertex, we want to look and see how the numbers change. You could also graph this to tell it, but I can see that starting at the vertex, the numbers in both directions, they're getting bigger going this way and getting bigger going this way, which means this is going to open up and the A value is going to be positive. So when you look at this, how do you make a -2 into a -1? And that's by adding 1. So on either side of your vertex, you should see the same thing, and that gives you your A value. So we have an A value of 1. We have H and K from your vertex. So H is -1 and K is -2. So when you write your formula, you have Y equals A is 1, X minus H is -1, and plus K. And because we have that 1 on the outside, I'll actually write this as the minus a negative just to make it a little more visual. So we're doing minus -1. So when you minus a negative, it becomes a positive. When you have an implied 1 out front, you don't actually have to write it because multiplying by a 1 changes nothing. So this would be the more simplified expression, the more simplified equation for that function. So the next one, the area of a square with a side length x. So the first thing I'm going to do is draw it. It says is decreased by 3. The side length is decreased by 3. The area is multiplied by 2. So in order to find the area, all sides have to be the same. So I can already tell I'm doing x minus 3 times x minus 3, which is the same as x minus 3 squared. So then it says the area is multiplied by 2. Remember that x minus 3 squared was my length times my width. And then 4 units are added to the area. Put a y equals up front, and you have your equation. All right. So then the next one, it says, let's graph the following in vertex form based on the knowledge you have. So again, the first thing I like to do is actually write vertex form, the general format of vertex form, near my equation so I can see all of the parts. So the first thing I notice, A value is negative, so it's going to open down. It's a reflection over the x-axis. It opens down. Then I also noticed that there is no parentheses, so there's nothing inside of the parentheses with x, which means my h is 0. And then my k value, the amount added on to the end, is 3. I have a vertex of 0, 3. I forgot to write a equals -1 on, or a equals -1 on here. So we start at the vertex, 0, 3. Your A value is telling us it opens down, and as we go to the right one, we go down 1. As we go to the left one, we go down 1 because it's symmetric, so it follows the same path. And at this point, you can just rough hand sketch your parabola. It doesn't have to be perfect at this point. So then the next one. Again, identify everything you know. All right, so the A value is 1, which means it's going to open up. It also means on either side of the vertex, you're going to go over one box and up one box. So then we have a h value. So in order to do minus h, you can rewrite this as x minus -2 because we have that plus 2 inside the parentheses. The way you make that plus 2 is you're subtracting a negative. So your h value is -2. Your k value is what's added on to the end. So your k value here is -5, which means your vertex is -2, -5. So the first thing you have to graph is that vertex. So we're going to go to -2, -5, and put our first dot. We know it opens up because the A value is positive, and because the A value is 1, when you go to the left and to the right of the vertex, you're going to go up one box. And then you can draw your parabola from there. I'm going to actually, we're going to do this next one together because it's different. So when we look at this one, we have y equals ax minus h squared plus k. So your a value is 3. It's going to open up because that's a positive 3. We have our h value. So remember, it's minus h, and this is -1, so your h equals 1. And then your k value is added on to the end, so k equals 2, which means your vertex is at 1, 2. So the first thing you need to do is graph that vertex. So we go 1, 2. Now on this one, your a value is 3. So when you go one box to the right of your vertex, you go up 3. And you go one box to the left of your vertex and go up 3 because of that a value being 3. And then you can draw your parabola. And then we're on to the last one in this section and the last one on this paper. So we have y equals ax minus h squared plus k. So on this one, your a value is 1/2. It's a positive 1/2, so we know it's going to open up. We also know on either side of the vertex, we're going to go over a box and then go up because it opens up half a box. So we're at another situation where there's nothing inside of the parentheses with k, which means that with x, which means your h value is 0. And then k is what is added on to the end. So this k value is -6. Vertex is hk. So your vertex is 0, -6. So plot your vertex first, 0, -6. And then because your a value is half, you go over to the right one box, and then you go up half of a box. Go to the left one, up half of a box. And there's your parabola. So it's a little bit more open this time because of that horizontal stretch created by that half multiplier, that a value of 1/2.